The lines L and M have equations given by these equations. Relative to origin O, the position vector of the point P is 4i plus 7j minus 2k. Given that L is perpendicular to M and P lies on L, find the values of constants A, B, and C. All right, so we are told that these two lines are perpendicular. Line L is perpendicular to line M, which means the dot product of their this direction vectors would be 0. Let's do that. That should be able to give us the value of C. So we're going to write C minus 2, 4 dot 2, negative 3, 1 equals to 0. So 2C plus 6 plus 4 is equals to 0. C is equals to negative 5. Okay, now we also have to find the values of constant A and B. What are we told? That P lies on line L. That's line L and that's P. So now we're going to equate 4, 7 minus 2 to the vector line A plus C lambda, 3 minus 2 lambda, and B plus 4 lambda. Okay, we already know what is C. C is negative 5, so I'm writing negative 5 lambda here. Okay, so I can solve the middle equation and get the value of lambda. So 7 is equals to 3 minus 2 lambda. That would be 4 equals minus 2 lambda. So lambda equals negative 2. Okay, now I'm going to substitute that in the first and the third equation to get A and B. So 4 is equals to A minus 5 times negative 2. That's a 10, and then that's a negative 6. A equals negative 6. Similarly, minus 2 is equals to B plus 4 times lambda, which is negative 2. So that's a negative 8. When it goes to the other side, becomes plus 8. So we get a 6. So these are the values of A, B, and C. Okay. Part B. Perpendicular from P meets line M at Q. All right, so let me draw P. P is a point which is 4, 7, minus 2. And the perpendicular from P meets the line M at Q. M is the other vector line given to us. This line, let me draw that line. And this equation of this line is R equals 1, 2, 3 plus mu 2 minus 3, 1. Okay. Perpendicular P, the perpendicular from P meets M at Q. So that's P. And the perpendicular from P meets M at Q. This is the perpendicular line. And this is the point Q. Okay. The point R lies on PQ extended with PQ ratio Q is 2:3. All right, so let's extend this line. So it says, let me read that again. The point R lies on PQ extended with PQ ratio QR is 2:3. So somewhere over here, this would be R, and this is 2:3. Find the position vector of R. All right. So the first thing we need to do is somehow find this vector. All right. For that, we know the steps to find foot of the perpendicular. Step 1 is write down the position vector of P, which is 4, 7, minus 2. Then the position vector of Q, which is the foot of the perpendicular, and that is the same as the line it's passing from. So that will be 1 plus 2 mu, 2 minus 3 mu, and 3 plus mu. Okay, we're going to take the dot product. Sorry, we're going to find PQ first, and I need to find this vector PQ. So PQ would be OQ minus OP. So I'm going to subtract these two. So that would be minus 3 plus 2 mu, then negative 5 minus 3 mu, and 5 plus mu. That is PQ. Okay, now we know that the dot product of this PQ and this direction vector would be 0, because this direction vector is actually parallel, parallel to the yellow line, and hence the green line, that is the direction vector, is also perpendicular to PQ. So if they're perpendicular, their dot product must be equals to 0. So minus 3 plus 2 mu minus, what's a mu? Minus 5 minus 3 mu, and 5 plus mu dot the direction vector 2 minus 3 1 is equals to 0. Now let's find mu from here. It's going to be minus, multiply these two. So minus 6 plus 4 mu, then plus 15 plus 9 mu, then plus 5 plus mu is equals to 0. That's a 14 mu equals minus 14. And hence mu is equals to negative 1. Okay, so if mu is equals to negative 1, that means we can find the vector PQ. So then the vector PQ, which was this vector, would be negative 5, negative 2, and 4. Okay, that's the vector PQ. All right, now somehow I need to find the position vector of R. I can find PR using this relationship. We know that, look at this, that PQ ratio QR is 2 by 3. Let me write that down. Two ratio 3. So that means PQ has 2 parts and QR has 3 parts. So PR total has 5 parts. Okay, so we already have PQ, which has 2 parts, and we've already established that PR would then have 5 parts in total, and we cross multiply them. So 5 PQ is equals to 2 PR, or 5 over 2 PQ should be equals to PR. I've used ratio here. So now I can find PR by multiplying PQ by 5 by 2. Okay. So PR is 5 by 2 times PQ, which gives negative 25 by 2, just 5, just negative 5. Sorry, 5 by 2 times minus 2 is negative 5. And then 5 times 2, that's 10. All right, so now we have vector PR and we already have the coordinate P. So when we add these together, if I write 4, 7, minus 2 in column vector form, and then if I add direction of PR, which is negative 25 by 2, negative 5, and 10 to it, that will give me the position vector of R. So what have I done for position vector of R? I'm adding the coordinate of P, which is OP, to PQ, sorry, to PR, which gives me OR. All right, so when we add these together, we get negative 17 by 2, 2, and 8. And that is the position vector of R. We write that in IJK form.